Okay, good morning once again, guys. Today we're going to continue our discussion on linear regression. Okay, so last time we started learning how to use R in to do linear regression. Okay, so we're using the wage data set. The wage data set, as we discussed last time, has 8 variables: education, experience, tenure, race, gender, civil status, number of dependents, and hourly wage. If we take a look at the data set, we notice that 3 here are categorical and 5 are quantitative. So we're interested in knowing the relationship between the independent variables or your predictor variables or your explanatory variables on our outcome variable or response variable or dependent variable. These are other names for dependent variable, which is hourly wage. We'd like to see how education or experience or tenure or even the categorical variables, race, gender, civil status, and another quantitative variable, number of dependents, have an impact on hourly wage. Okay, if you recall, guys, from your earlier statistics subject, if you're going to write a paper about this, and suppose you'll first identify the objectives. Okay, if you're going to identify the objectives, let's have a quick review. We define our null hypothesis 1, for example. Okay, so let's make this $, H, and then 0, 1. Okay. Let me just do this. Okay. So this is equal to. Okay. So just as an example, there is no significant relationship between EDUC and hourly wage. Okay. Ay, nako. I need to, okay, sorry about that. I need to put spaces here. Okay. So anyway, matatagalan tayo sa oras, ano. So this is our, ano na lang, I will not anymore. Inline na lang. Okay. I will have to put spacing. Anyway, ganito na lang, guys. So yung null hypothesis natin, so let me just remove this. H01, there's no significant relationship between education and hourly wage. And of course, the alternative hypothesis is there is a significant relationship between education and hourly wage. Okay, I noticed, guys, sa mga research paper, ito yung karamihang weakness ng mga students. They don't know how to write hypothesis. So we're looking at the effect or the relationship between each of the variables on our dependent variable hourly wage. So we have to write the null hypothesis for that, which is H01. Okay, there is no significant relationship between education and hourly wage. Of course, the alternative hypothesis is there is a significant relationship between education and hourly wage. And you do the same for the other variables. Okay. So last time we also looked at we used some of these functions in order to understand more our data set. Okay, we'll just skip that. And then ito, di ba? Prinat natin to, di ba? For some reason, di yata nag-plot sa akin to last time, so let me plot this. Okay, here. Okay. Yeah, I recall last time hindi nag-plot sa akin to. Okay. So we can see here the plot between hourly wage and your years of education. Okay. Usually when you plot, guys, your variables, ang linalagay natin sa y-axis is your dependent variable, and then sa x-axis yung years of education. Now, if you take a look at the relationship between years of education and hourly wage, mukhang merong ano, no? mukhang meron namang relationship between them, no? Kasi if you take a look at this, parang may okay, there seems to be a positive correlation between hourly wage and years of education. Of course, we can easily check that, which we did last time by looking at the correlation between the two. Okay, so let's just have a quick review again. Next ko na to. By the way, guys, I already posted yung recording nung last time, ano? Okay. So, did we nag-correlation ba tayo dito? Ito. Ito. Okay. So, it's important, guys, to determine the correlation, okay, correlation between wage, education, and wage. That's your hourly wage. Hourly wage. Okay, 0.4. So there's a medium yung correlation nila. Hindi very strong correlation, hindi naman din weak, but nasa medium lang siya, no? Yung correlation between education and hourly wage. We want, guys, that the independent variable, the explanatory variable, to have a high correlation with your dependent variable. The higher the correlation, guys, ibig sabihin, the higher will be the chance that the independent variable will be able to explain your dependent variable. Okay. So that goes for all the other predictor variables natin, yung 7, no? Except for the categorical variables. And what we want is that we want the correlation between your independent variable and your dependent variable to be high, but we don't want the correlation between your independent variables to be high. Ayaw natin nun, guys, kasi magkakaroon tayo ng what we call autocorrelation, no? We don't want autocorrelation for our model kasi pag autocorrelation, guys, sorry, not autocorrelation, multicollinearity, I stand corrected. Multicollinearity. Pag multicollinearity, guys, it will be difficult to pinpoint ano yung contribution ng isang variable in explaining the variance of your dependent variable. Since they are highly correlated, yung dalawang independent variables na yun, hindi natin makikita masyado kung paano, ano yung impact ng bawat isa on explaining your dependent variable. So we want that your independent variables to be as much as possible not highly correlated, no? Okay, and we can inspect that. Okay, I think last time we also looked at this. Okay, we did this, diba? So just for this, we attached, I recall, I think I explained to you na kasi if we want to use, okay, let me go back here. Take a look at this code, diba? Ito, we had to identify that yung wage, yung education at saka hourly wage, they're from the wage dataset. Okay, so every time you make use of a variable in a dataset, you have to identify kung saan dataset galing yun. Now we can of course just use the variable itself, but we have to attach you have to attach the data set. When we attach a data set, what we're doing is that we're telling R that lahat ng mga variables sa susunod na gagamitin is coming from that data set. Okay? Okay lang yun guys kung iisa lang yung data set na ginagamit natin. Pero pag marami guys, that might be difficult to monitor. So pwedeng gawin nyo yun, i-attach nyo siya. Then when you're going to use another data set, i-detach nyo naman siya. So let me illustrate that. So here I'm going to attach wage there. And then kunin natin correlation. So we got the same 0.405. Okay? And then we looked at this one last time, correlation ng wage. Nag-error siya. Bakit siya nag-error? Kasi wage as a data set contain, may mga categorical variables yan. And there's no correlation. Okay, let me illustrate that. No? Walang correlation ng, kunyari, core. Since naka-attach na yung no? I can just use race and gender. I can use this kasi na-attach ko yung kanina, yung wage. No? So R will understand that this is coming from the wage data set. But if we get the correlation between two categorical variables, mag-error siya. Kahit nga guys, correlation between educ and race kunyari. Educ is a quantitative variable. Race is a categorical variable. If you get the correlation of that, wala. No? Hindi pwede magkaroon ng correlation pag categorical variable. Okay? So, yung code natin dito, yung code natin na to, ito, correlation ng wage, error siya kasi may mga categorical variables dun sa sa wage, no? So here, correlation ng wage, ang ginawa natin, we remove the sinubset natin, tinanggal natin yung columns 4 to 6. So this one means that the whole row is still there. The whole row will be maintained. Tapos sa column, babawasan lang ng 4 to 6. Bakit babawasan yung 4 to 6? Kasi si race, si gender, at saka si civil status, these are the categorical variables. No? So let's run this. Okay. So here we have the correlation between the quantitative variables now. Ilagay ko nga lang guys kasi masyadong malaking decimal place. Mag-round lang tayo ng, just copy this. Control C. Control V. Okay, comma. Round it to 3 decimal places. Okay, para lang mas, okay, there. Okay, so I think we discussed this last time that we want the correlation between your dependent variable hourly wage with the independent variables to be high. Okay, so yung pinaka malamang na pinaka makakapag-explain kay hourly wage is education, having the highest correlation among the different independent variables. Ang pinakamaliit si number of dependents. Okay? So si number of dependents most likely is the one that has the least capability to explain hourly wage. Okay? And then you have here tenure comes next, and then experience. Okay? So and kunyari si tenure naman, if you're going to take a look at its correlation with the other variables, medyo mataas yung correlation niya with experience, no? 0.499. So we don't know, this might have an issue with multicollinearity, no? Pero otherwise wala na namang ibang malalaking correlation, no? So we may or may not have problem with this. I think this is the highest pinakamalaking correlation. It's between tenure and your experience. And we said that, just to reiterate this, we don't want your independent variable to be correlated with the other independent variables. Ayaw natin nun. Gusto natin yung dependent variable highly correlated with your independent variables, but the independent variables correlated with the other independent variables, we don't want that. Okay. Right. So we started here last time. Ito, no? Nakapagsimula na tayo dito. Here I'm creating a model, okay? I'm creating an object. We're calling it model 1, mod 1. And then we learned last time to make use of the LM function. Yung LM function, guys, tingnan muna natin question mark LM. It always pays to get the help function. So this is from the stats package, and there was no need for us to load this in stat package kasi kasama siya na kasama na siya sa base R. Okay, LM is used to fit linear models, guys, including multivariate ones. It can be used to carry out regression, single stratum analysis of variance, and analysis of covariance. Although ACV, AOV, okay, analysis of variance may provide a more convenient interface for this. Okay, so ayan yung syntax, no? And usually nagbibigay siya ng examples ito, no? For example, may mga example dito. Okay, I suggest that you also run this. Okay, dito kinukuha muna yung it's creating a data set here, CTL, TRT, another data set, and then nag-object siya na group. Okay, this is the function G1. Okay, and then nag-regress siya dito, no? Regress yung weight on the group. Okay, so back to our example, guys. So yung LM function, the syntax is you start with your dependent variable and then tilde education, and then you describe what data that's coming from. Data is equal to age. Okay, by the way, here a while ago, sorry nakalimutan ko to, di ba nag-attach tayo ng nag-attach tayo ng wage. Now, if you're going to use other data sets, then you can detach this. Pwede natin detach si wage. Okay, that means na hindi na si wage yung data set under consideration. All right. So last time we run this model, si mod 1, I run this. Okay, tingnan nyo, no? So si mod 1 object, it's a list of 12. Let's take a look at this. When we create a regression model, the output is a list. So iba-iba yung laman niya, no? May coefficient siya. Okay, if I click this, yan. Coefficients, andyan yung intercept, andyan yung slope. Residuals, if I click this, so ito yung mga error terms. Yan yung mga error terms, and there are 500 plus error terms because yan. 500, ilan yung natin? Ilan yung data set natin? 526. Therefore, 526 error terms then, residuals. Ano yung residuals, guys? It's the difference between your actual value and your predicted value. Okay, we'll take a look at that in a while. Papakita ko yung example just to clarify that. Okay, and then we can generate the output. So ito yung model 1 natin, ito yung regression output natin. So we're able to generate this. So this recalls the formula. At linear model, ang formula natin, hourly wage, regression, education, data is equal to age. By the way, guys, this is an example to, di ba? Simple linear regression lang to. Kasi isa lang yung predictor natin. Pag maraming predictors tayo, we have what we call a multiple linear regression. Ang assumption natin, guys, yan, dapat yung dependent variable natin, dapat continuous variable. Quantitative dapat siya, continuous. Hindi siya pwedeng categorical, hindi siya pwedeng binary. So, ibang method pag binary yung dependent variable natin. Pero, for the independent variable, walang restrictions. No? Pwedeng categorical yan, pwedeng quantitative. Okay, so it gives us a summary statistics ng residuals natin. And then here is our regression output. intercept is negative 0.9, and then education is 0.54. Okay, then we have the standard error, and then the t-value, which is computed by the estimate. Okay, so yung t is estimate, yung bait, sulit ko muna dito, no? B divided by your standard error. So that's the formula for your t-stat, no? You recall from your stat before, that's your t-stat. So if you try, let's try this. So our B is this one, Control C, Control V, divided by the standard error, Control C, Control V, then you have your t-stat, negative 1.321. And yung p-value niya is 0.187. Okay, question. Is this p-value significant or not? Anyone? Significant ba siya? Significant predictor ba yung intercept natin in explaining our dependent variable hourly wage? Kindly chat please or unmute yourself. Na OQY. Kindly unmute na lang please.
Hello, sir.
Yes. Bakit hindi siya significant?
Di ba po dapat 0.05 and below?
Okay. So, depende dun sa level of significance. Usually, ang ginagamit na level of significance is 0.05, no? Okay. Usually, ang ginagamit na level of significance is 0.05. Okay. So, the test is if the p-value is less than 0.05, then reject our null hypothesis. Okay. What is the null hypothesis here, guys? Ano yung null hypothesis dito? Anyone? Ang null hypothesis dyan is okay. If you recall, guys, ito yung analysis of variance natin, no? Analysis of variance. Ano yung null hypothesis natin dyan? Anyone? Okay, meron ng chat. Okay. Ano kaya ang null hypothesis dito? Firstly, guys, ang tawag sa table na to? This is your ANOVA table. No? That's your analysis of variance table. And then, ano yung null hypothesis dyan? Null hypothesis that beta null is equal to 0. Beta null natin yung intercept. No? Tapos yung sa isa naman, yung sa education, ang null hypothesis natin dyan, beta 1 no? is equal to 0. So those are our null hypotheses. Na beta null is equal to 0 for the intercept. For education, beta 1 is equal to 0. So ang ano natin, guys, ang conclusion natin, ang inference natin for the intercept is that we reject or we fail to reject the null hypothesis. Since the p-value is greater than 0.05, then we fail to reject the null hypothesis that beta null is equal to 0. So there is a strong probability that your intercept is equal to 0. Is equal to 0. Okay, so I'll explain in a while pag inon natin equation. And then yung H ano naman, so this is HO1, this is HO2, no? Second hypothesis natin. B1 is equal to 0. which is, what do we conclude? What do we infer here? We reject the null hypothesis that beta 1 is equal to 0. Okay? Kasi this value is less than 0.05. Ano ibig sabihin ng 2e to the negative 16? What does that mean? Ano ibig sabihin ng 2e to the negative 16? It means, guys, na 2, okay? Tapos, from 2, guys, from 2, you'll go to the left and add zeros. You're going to add 15 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so ito yun, no? This one, guys, 2e to the negative 16 is this number. So from 2, bilang 1, 2, 3, bilang ng 16, no? So this is that number. And obviously, guys, this is less than, way below, less than 0.05. So ang conclusion natin dito, here, is that we reject the null hypothesis that education is equal to 0. Okay, there's strong statistical reason to believe that the coefficient for education is not equal to 0. In fact, here the estimate is 0.54136. Okay. Now, with this, guys, we can now have our model. Our model now will be hourly wage. Okay. I can write it here. So that's why yung model natin. Hourly wage sub I is equal to Control C, Control D, plus Control C, this one, and then times times, and we have educ, diba? Underscore I, okay, plus a certain error term. Gawin natin itong epsilon, no? Okay, ano nangyari? Error unexpected dollar. So, let me run it here. Okay. Hindi siya nag-run dito sa console. Okay, so this is our equation, guys, our regression equation. Our hourly wage is equal to your intercept, negative 0.90485, plus the coefficient of your dependent variable, and then times education, plus a certain error term. Okay, let's invest some minutes on discussing this. Okay, remember, guys, ang regression natin, we're trying to establish a relationship between your dependent variable. Okay, thank you, Naoki. Yes, that's correct, no? Dependent variable, hourly wage, and your predictor, which is education. Simple linear regression lang muna tayo, no? And we use education kasi nakita natin about the correlations ng dependent at saka independent variables natin. Si education ang may pinakamalaking correlation. So kung isa lang talaga yung pipiliin natin, pinili natin si education as a predictor. Okay, so what does this mean, guys? Yung negative 0.90. What does that mean? Anyone who can explain the meaning of that negative 0.90? I'm sure you have met that in your previous stat subjects. Ano ibig sabihin ng negative 0.90, guys? It means, okay, this is the value of your dependent variable. If all your predictors are all equal to 0. Okay? So ano ibig sabihin itong negative 0.90? Okay? Ibig sabihin yan yung hourly wage daw of an individual among our respondents if your education is equal to 0. Kasi guys, pag 0 yung education, so you replace this with 0, diba? Let me annotate that. Saan ba yung color dito? Okay. Okay. Education guys to. Education. 'Di ba sabi natin yung intercept na 0.9, this is the value of your hourly wage if education is equal to 0. Ano ibig sabihin is equal to 0? Walang years of education yung tao. So, ibig sabihin nun guys, negative 0.9 yung hourly wage niya in dollars. Siya pa yung magbabayad sa company. Okay? So, yung intercept natin guys, it becomes ridiculous, no? It becomes ridiculous kung titingnan natin, okay? So we don't put so much emphasis guys on the interpretation of the intercept. Okay. Also guys, 'di ba not significant yung significant ba yung intercept, guys? Paki-chat please. Significant ba yung value? Statistically significant ba siya? Hello guys. Hello, please kung pwedeng sumagot. Okay, no. Okay, correct. Thank you. No. No siya, di ba? Kasi we just looked at the p-value, di ba? Okay? And also the t-value, guys. Usually kapag for 5% significance level, the t-value should be around 2 something, no? Ito mababa, negative 1.3 lang. Okay, so ang probability niya is greater than 0.05, no? So we now have here intercept natin is not significant. So should we include that, guys, in the regression equation natin in our model? Di ba hindi siya significant? Pag hindi ba significant, sinasama pa rin natin siya. Okay, kapag yung pag independent variable, guys, hindi significant, hindi siya sinasama. Now, ang practice, yung intercept, kahit na hindi siya significant, sinasama pa rin siya sa model. Okay, we still include it for purposes of prediction. So we still use the intercept. No? Okay, so if you take a look at our data, di ba, wage, yung education. Okay, tingnan natin guys kung ano ba yung minimum value ng wage education. What's the minimum value? 0, no? So meron ding mga respondents dito sa data natin na 0 yung years of education nila. Okay, balik tayo dito sa model natin. Okay, so practically guys, hindi naman natin pwedeng sabihin na ang isang tao na walang education, yung yung hourly wage is negative 0.9. Okay? So we don't attach too much a practical significance on that kasi hindi naman pwede yung negative na 0.9 yung hourly wage ng isang tao, no? However, we still use this and include the intercept in our model. No? Okay? So once again guys, yung interpretation itong intercept na to, this is the value of your dependent variable when all your independent variables are equal to 0. Okay, so education in this case is 0. Ibig sabihin walang education, years of education. So we put here 0 and then guys. And then so 0 times this, Diba? Zero out yan. So, ang matitira ito na lang. So, that's the value of your hourly wage. Okay, so let's copy ko ba? Okay. I'm going to use this further. Copy ko siya. Okay, so what will be the hourly wage for a person number 1? So person number 1 has 11 years of education, di ba? Okay, let's predict ano yung magiging niya. Ano yung magiging hourly wage niya. So if we replace this by 11, kasi 11 years yung ID number 1, person number 1, what will be the hourly wage? So let's see, guys. So the hourly wage is 5.50011, no? So tingnan nga natin yung model 1 natin. Tingnan muna natin ito guys, fitted values. Ayan. Fitted values, tingnan nyo to. No? Ayan, observation number 1, ang fitted value niya, ang predicted value niya is 5.501, which is this one. Yun. So that's where this came from, yung 5.501. Yun yung predicted value. So we use the equation in coming up with the prediction. So that's 5.501, no? Okay. Tapos ano ba yung actual value ng person number 1? Ano yung hourly wage niya? The hourly wage is 3.10. Yan. Person number 1 has an hourly wage of 3.10, and then the predicted value is 5.501. Ito. So based on the model, yung predicted value niya natin is 5.501. So that means, guys, that there's a discrepancy, no? Okay. The difference between that is what we call our residual. Enter natin. So this is the difference, negative 1.95, which means that our residual is negative 1.95. So tingnan nga natin sa model natin, And then let's take a look at our residuals. Ito. So, ano yung residual daw ng unang observation natin? Negative 1.95. Ba? Oh, sorry. Hindi ko na copy. Control C. Ayaw. Hindi ko makopya. Okay, but negative 0.9501. So tama, no? Tama, guys, yung that's how you generate the residuals, that's how you generate the fitted values. Okay? So the residuals is simply the difference between your actual value, kasi may actual value tayo, ito, yung hourly wage. And then minus the predicted value. The predicted value is, use your model. Ito yung ginamit natin na model. So this is our predicted value. Then get the difference between your actual minus predicted. Then you have your residual. Okay, let me pause for a while. Comment please. Are there any questions? Please, pakisabi kung clear so far. I would appreciate your feedback, guys. Let's wait for the others to give their feedback. I hope all of you are you're understanding my explanation. Okay, good. Thank you so much. So I think magkakasummer ng FINSTAR, no? If you're going to enroll there, we'll have a brief review of this. Tapos kasi panay regression yun, at time series. Okay, good. Thank you. Thank you for your feedback. Thank you for your comments. Mukhang clear naman lahat. Okay, so let's continue, guys. Okay. Now, let's plot, guys. Na-plot na natin to, no? Ito ginawa natin last time. So ito pina-plot natin si education on the x-axis and hourly wage on the y-axis. Nilagyan natin ng label, yung x-axis, x-label, y-label, plot character, and then frame is equal to false. Ibig sabihin huwag lalagyan ng ng line, ng border. Then binago natin yung x-axis, and then ito, guys, maglagay tayo ng horizontal ng line, guys. AB line is the line for your, it's a line And yung line na yon is the regression line, no? Ito. AB line, okay, LM ng hourly wage and education. And then we said that it's a colored blue. Let's plot this. Oops, dali. Ito. Bakit hindi lumalabas yung AB line ko? Let me repeat. Kasi nagkakaproblema itong... Okay, I'm having a... Did it translate you guys? Hourly wage. Ay, sorry. Okay, may kulang ako dito. Dapat, sorry, data is equal to wage. Okay. So, example guys, no, ito, LM, hourly wage and education. Nakalimutan ko yung data. So, hindi alam ni R, teka muna, ano yun? Wala akong alam na hourly wage at saka education. Kasi si hourly wage at saka si education, variable siya ng wage data. Okay. So, okay na to. Let's run this. Okay. So, here we have, guys, your plot. On the y-axis, your hourly wage. On the x-axis is your years of education. And then here you can see the regression line. Itong regression line na to, guys, itong regression line na to, ito yung ano natin, yung negative 9, yung equation natin kanina, negative 0.09 something, yep, isulat, plus, ano yung ano natin, ano yung, wait, ano yung intercept, ano yung slope natin guys, 0. Ano? Paki-dictate nga, unmute na lang. Please. 0. What? Yung slope, please. Hello, anyone, please?
0.54136.
5.4. Okay, i-shorten ko na lang 5.4. 5.4 times education. Hirap isulat nito. Dapat naka-ano, digital pen. Okay, so this is our model, di ba? Ito yung line na yon. This is that line. Okay. Okay, and then these are the actual data points. And then yung residual natin is this distance. Yan, yung distance yan. Yan yung residual natin. It's a difference between your actual and your predicted value. Yan. So we have those lines, no? We have those lines. Okay. Now, if you sum up, pag inad natin lahat ng mga residuals natin, what do you think will be the answer, guys? Error 1, error 2, error 3. Okay, so yung error dito, guys, positive, no? Positive yung mga error dito. Kasi ito yung actual value natin, di ba? We drop a line there. Actual value minus the predicted value. Since your actual value is greater than your predicted value, then your error term will be positive. On the other hand, ito naman, guys, ito. Those are negative error terms. Kasi actual minus predicted, yung predicted natin mas mataas, then you have negative values. Now, if you record all of these points and their residuals, what will be the sum of the residuals? Anyone? Ano sa tingin niyo yung sum ng mga residuals? Okay, may nag-chat. Okay, thank you, Naoki. No? Salamat. You're correct. The sum of these residuals, guys, will be equal to 0. Equal to 0 yan. Okay? So, what method is being used for simple or multiple linear regression? The method is what we call OLS. Okay? OLS stands for, I'm sure you have met this term before, ordinary least squares. Okay, and by least, it's L-E-A-S-T, no? yung pinakamaliit na squares. Now, paano nangyayari yun, guys? How is this regression line determined? Paano nakuha tong line na to? Bakit hindi siya pag ganito? Or bakit hindi siya pag ganito yung line na yan? Why? Now, first and foremost, guys, there is only one and only one unique regression line for any data set, no? Iisang regression lang yan. Unique yan. Hindi pa pwedeng dalawa. Hindi pa pwedeng either one line or another line. There is only one and only one line, which means that there's only one intercept and one slope that can describe your regression line. If it's a simple linear regression, iisa lang yung slope na yan, iisa lang din yung intercept na yan. And the method that's used is what we call ordinary least squares. Okay, we don't use the errors, no? Kasi pag sinum up natin yung mga errors, zero lang yan. What we use is we sum up all your residuals squared. Okay? So we square the residuals. Kunyari itong residual na to. We're going to get the square of this. Okay? Whatever this residual is, yung amount, and then ini-square yan. So lahat ng mga residuals, guys, it's, sorry for the crude drawing, ini-square siya. Yan, yan. That's where we get the ordinary least squares. And that regression line is the line where the sum of your squares, yan, yung error squared, the sum of all this, pag in-square natin lahat ng error, tapos i-sum up natin siya, it's the one that has the minimum value. Minimum value siya. Okay? Siya yung line na mabibigay sa atin ng pinakamaliit na residual squared. Okay, questions so far, guys? Any questions? Okay, so no questions. So let's let's continue. Oops. Kailangan tanggalin yung ano. Okay. All right. So we have we have discussed the meaning of yung intercept na to, no? What about point 54? What's the meaning of point 54? Okay, thank you, Angel. Okay, the slope, sir. Okay, that's correct. It's the slope of the regression line, point 54. But ano yung meaning niya? Ano yung interpretation nito? Okay, ang interpretation nito, guys, na for every 1 year increase in education, there's a corresponding $0.54 increase in your hourly wage. So this is the marginal or incremental change in your dependent variable for every 1 unit increase in your education. Okay, so 0.541 change in hourly wage per 1 year increase in education. That's the meaning of 0.54. So for example, if education increases by 2 years, then the increase in hourly wage will be 0.54 times 2. Yun ang ibig sabihin, guys, ng slope natin. 0.54 means there's for every 1 year increase in education, there's a corresponding 54 centavos increase in your hourly wage. Okay? So let's take a look. Ano pa ibang makukuha natin dito, no? Okay, the three stars here. Ano ibig sabihin ng 3 stars dito? This one. 3 stars, guys, means it's significant at 0.001. Yun yung 3, no? Pag nakita natin dito sa R, pag 3 stars, ibig sabihin, this value is less than 0.001. So it's significant, kaya 3 stars, it's significant at 0.1%. Okay? If it's less than 0.01, then makikita natin 2 stars. If it's less than 0.05, then ang makikita natin is 1 star. If it's just a dot, pag may makita kayong dot niyan, ibig sabihin yan, significant at the 10% level. 0.1. It's less than 0.1. Okay? So yung range ng ano natin, ng p-values ranging from 0, between 0 and 1. Okay? Alright, pag tatlong asterisk, guys, ibig sabihin very highly significant, no? Kasi less than 0.001 nga, less than 0.1%. Pag dalawa naman, less than 1%. Pag isa, which is usually what's used, social science or econometrics, okay? Significant level of significance is 0.05. Okay, how about this, guys? Standard error ng residuals natin. Okay, we will use this more in the future. 3.378 on 524 degrees of freedom. Okay. Now itong multiple R squared at adjusted R squared. What does this mean? So let's just use first itong adjusted R squared, 16.32. Can anybody tell the class what's the meaning of 16.32 itong adjusted R squared na to? Yes.
I think po the R squared measures the goodness of fit of the regression model. So the higher it is, the more fit the model is. So if it's lower, then it's the opposite na it's not a good fit.
Okay. All right. That's thank you so much. Okay, but i-clarify lang natin in general, the higher the adjusted R squared, okay, the better is the model fit. Okay, that's partly correct. However, guys, next, there will be some instances na kahit mataas yung adjusted R squared natin, lumalabas na hindi magandang fit, no? So, but generally, guys, tama yon. But technically, guys, anong ibig sabihin nitong 16.32 na to? Ang ibig sabihin to, let me write it here, that yung adjusted R squared natin na 16.32 means that 16.32% of the variation in the dependent variable hourly wage can be explained by the explanatory variable education. Okay, so that's the technical definition of that, no? And we normally use adjusted R squared, which I'm going to explain later on kung bakit adjusted R squared. Okay? May konting difference sila, especially kung sa multiple linear regression, importante yung difference na yun. Okay, 16.32% ito of the variation of the variability in this is dependent variable, dependent variable, okay? Dependent variable, which is hourly wage, okay, can be explained by the explanatory variable education. Okay, 16.32% lang ang kayang i-explain ni education on the variability of your dependent variable hourly wage. Now, ano nangyari dun sa 83+%? Well, it could be explained by other variables, no? Pero kung education lang, guys, 16.32% lang ng variation ni hourly wage ang kaya niyang i-explain. Now, do you want a higher adjusted R squared? Generally, yes, guys. So what do? Use other variables to explain your hourly wage. Kasi ngayon, iisa lang yung variable na ginagamit natin. Si education lang. At ang kaya lang na explain education is, ano lang, si 16.32. Okay? So that will bring us now to what we call yung multiple linear regression. Okay, so ito yung equation natin, ano? Okay, tapos plinat natin yung AB line. Okay, let's move on here. Okay. Now, when you come up with the regression model, guys, it's not enough that you stop there. May model na tayo. Ito na yon. Hourly wage is equal to this quantity, this function. Okay. Do we stop there? No. Okay. Importante sa steps, importante guys sa statistical analysis using linear regression is that we go to diagnostics. No? We go to diagnostics. Tingnan natin guys kung yung model natin comply with the requirements of the assumptions of linear regression. Ito yun. Diba? We're going to look at some of the requirements here. In particular, yung residual analysis. Kasi critical sa atin yung residuals guys, yung error terms. No? The residuals should follow should behave in certain ways. Kunyari, the residual should be what we call homoscedastic vis-a-vis heteroscedastic. Okay, so let's take a look at that. Okay, dito. No? So let's take a look at regression diagnostics or residual analysis. First, alam natin ito yung content ni di ba, ng mod 1. Diyan yung coefficients, residuals, and the unfitted values. Okay, we can call out yung residuals. If you take a look at this, guys, tanggalin ko na tong head na lang, no? Head ng res. Okay, here I'm creating an object called res, and galing siya sa model 1, then dollar residuals. So this is how we access any values or information from our model 1, the list. We use model 1 and then dollar residuals. So let's run this. Tapos yung pred din nga pala, itong pred. Okay, galing naman siya sa fitted values. So pred, gawin din natin head, no? Head ng pred 10 na lang din. Okay, so let's run this. Itong apat na to. Nag-create tayo ng object na res, and it's coming from the residuals of model 1. Tapos pinapaprint natin first 10. Ganun din yung predicted value. So let's run. Oops, sorry. Sumama yung names. Waiting ko na lang. Para ito lang ma-print. Yan. Okay. Tingnan natin kung kaya niyang i-round nga natin. Let's see. Or dapat dito siya. Will it work here? Let me see. Round. So 3 decimal places lang. Okay, yan. Tapos ito i-round din natin. Round. 3 decimal places. Okay, so let's run both. Okay. So yung first line natin dito, first 10 observations, these are your residuals, no? Tapos ito naman, ito yung predicted values natin. Okay, we know where this came from, di ba? Yung mga residuals natin. It came from the actual value. Lagyan natin dito. Head ng wage. Let me see if we can round dito siya. Okay, what am I doing, guys? I'm also printing yung wait, wage, hourly wage, sorry. Yung hourly wage, no? Okay. So ito siya, no, yung first okay. Actual value, guys, 3.10 minus the predicted value, 5.05. You get this, negative 0.195. So just to once again cite this example. So 18.18 minus 8.29, then you have this residual, 9.882. Positive yung mga residuals, guys. Pag mas malaki yung ano natin, yung actual value. Ibig sabihin dun sa plot natin kanina, above the regression line siya. Okay. So these are your residuals, no? And then what we can do is, okay. So there's this this package, yung Broom package. Pretty powerful package. Natin itong Broom. So what's this? What's the Broom package about? Ito ko na lang kunin, guys. Broom. Ito. So this is Broom. So ano yung description niya? Okay, package Broom converts statistical objects into tidy tables. So marami siyang ano, guys, no? Marami siyang functionality. You can research on that more. So ito, nasama ko ba yung Broom sa taas? Hindi. So if you don't have Broom, the Broom package, install nyo muna, guys. Since I have it already, I'll just record that. And then, okay, take a look at this. I'm going to create this object, mod1, diagnostic.metrics, and then I'm going to use the augment function. Ano ba yung ginagawa ng augment function yan? Broom. Augment. No? Okay, let's take a look at this. Bakit re-export siya? Broom. I think nga. Re-exports, binago na ba niya? Ah, ito. Augment, no? Pero this is from another object. This is from another package. Parang magulo tong help nila. Okay, anyway, wag na lang muna natin tingnan yung help na yan. Pero let's run this, yung model1.diag.metrics. And then let's see what the output is. Okay, run natin to. Okay, take a look at that. Hindi, i-ano natin. Let me get the head of this. Head. Mode 1. Sige. Kahit yung first 6 lang. Okay, take a look at this, guys. Okay, it gives us a neat output. Ito yung hourly wage natin. Okay. Ito yung independent variable natin, education. This is your predicted value. Okay. This is your residual. No? Saan nakuha to, di ba? Yung actual value, hourly wage, minus the fitted value is equal to your residual. And then it gives us some other measures, metrics. And then meron ditong Cook's distance. This is for your influential points, no? And then this is your standardized residuals. No? Okay, so it gives us, guys, yung table ng ng actual value, your independent variable, your predicted value and your residual in one data set, no? In one data frame. Okay, so let's try to plot. I-plot natin, guys. Ipa-plot natin dito yung coming from the our model metrics. Tapos ipa-plot natin si education, tapos si hourly wage, plus using geom point. And then gagamit tayo ng stat smooth method.lm. Don't put the standard error. And then gagawa natin, guys, ng segment. Okay? Sa x-axis will be ang dulo ng x will be education. Ang dulo ng y will be the fitted value. Lalagyan din natin ng color at saka ng size. Okay? So I'm not going to install ggplot2 anymore. Okay? Library lang natin. Okay. Sandali ha. Do you have this? Okay, plot the residuals, hindi ko pala linagyan. Sige. Okay, I want to be writing it, pero sige, i-copy ko na lang dito, guys, para hindi na kayo magtagal mag-copy. Okay. You may copy the chat, guys, in the chat box. You may copy the code. Of course, i-load nyo muna si ggplot2. Okay, and if I run this, Control Enter. Yan. Take a look at that, guys. You can use this sa sa project, no? Yung kahit sa multiple linear regression, kaya nang gawin yan. Okay, what do you see now here, guys? Ito yung pinapakita ko sa inyo kanina, no? Ito yung mga lines na yan, yun yung mga errors natin, yung mga residuals natin. So the black points are these are your actual values, these are your hourly wage, no? Itong line na to, ito yung regression line natin. So if you compare the actual hourly wage with the regression, so may red line yan, ibig sabihin yan yung residual natin. Okay? So bawat isa may residual. And then just by way of review, anong ginagamit na method in finding this? Paano nalaman to, guys? Paano na-solve tong intercept at saka slope nito? It made use of what we call, anong method, guys? OLS, di ba? Ordinary least squares. So, gagamit ng gagamit ng optimization. Kukompute nila, kukunin yung residual, tapos kukunin yung square ng bawat isang residual na yan. Ang dami yan, di ba? Then i-add yung residuals na yan, yung squared residuals. Take note, guys, ha? Hindi yung residuals, hindi yung E. Yung E yung distance na to. If you add those, everything, okay, zero yung sum niyan. Zero yung sum. Kaya wala tayong makukuha information doon, no? So ang ginagawa, guys, we square the residuals. And then when you square the residuals, you find that line, which we call the line of best fit. The line of best fit, or the regression line, okay? The line of best fit is that line where your squared residuals, the sum of your squared residuals is at a minimum. Yan. Minimum siya. So wala nang ibang line, guys. This is a unique line. Wala nang ibang line na mahahanap tayo na kapag sinama up natin yung mga squared residuals, mas maliit pa sa line na to. So for example, if I come up with another regression line, kunyari pag ganito. Oops, sorry pag ganyan kunyari. And then if you get the residuals and then square it, guys, yung value ng summation ng residual squared nito will be greater than itong blue line na to. Okay? So that's what we call the line of best fit. Siya na yung best talaga. Okay, it's already time, guys. Okay, so just this last one, ito lang para matapos tayo dito, no? Ito, ipa-plot ko lang to. Okay. Now, next meeting, guys, titingnan natin to. Ano to? Ano to mga to? This has a meaning. So next time we'll get it from here. When we meet next time, guys, pakibukas na kaagad yung file natin, and then i-ready nyo na, i-download nyo na yung i-create nyo na yung mod 1 kasi tuloy-tuloy pa tayo nito. And there are certain notes here, pakibasa kung ano ibig sabihin ng mga plots na yan. Okay? All right, so let me stop recording. Okay, thank you so much, guys.